Hello everybody. Today we're doing leak code number 49, group anagrams. Given an array of strings, STRS, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So for example 1, we see eat, tea, tan, ate, gnat, and bat. And with an anagram, we know that they're exactly the same length with the exact same number of character counts. So they're just like a scramble of each other. So for the output, we see that ate, eat, and tea are anagrams of each other because they're exactly one A in each word, exactly one T in each word, and exactly one E in each word. The same is true for this group, gnat and tan. There's one N, one A, and one T in each. And for bat, there's no other words that are just like it, so it's here by itself. So to go about this, we can iterate through each word, and for each word, we would iterate through each character and create a key out of it. So what that would look like, we start with our hash map, where on the left side, it's our key. So each word will have its own unique key, and that's how you group them all together. So for ate, eat, and tea, it will have one key that represents all three words, and another key, gnat and tan, that is specific for only gnat and tan. And this bat, BAT, will also have another key. So for this particular problem in example 1, there will be 3 keys in the object. Here we have the key on the left side and the array of words on the right side. So at our first iteration for eat, we know that we have to create a key out of it. So in order to create a key, we're going to loop through this string and figure out how many times we've come across these characters. So essentially we're creating an array frequency count. So the array would be a bunch of zeros in the beginning all the way to 26. This would be A. So let's say this would be A, B, C, D, E, F, G, T, and C. So they're just representations of this letter. And for every slot, we're just doing the count for them. So when we iterate through the eat string at character E, we'll find where E is, increase the count to 1. Then at the next iteration, we're at A, we'll find A, increase the count to 1. For T, we'll find T, and also increase the count to 1. So here we will create a string out of this array. So out of this array, we'll create a string. So we'll turn it into 1, 0, 0, 0, 1, 0, 0, a bunch of zeros, another 1 that's for T, and that's your key. So we take this key for eat, we go into our hash map, and we try to find this key. This key isn't available, so we're going to take this key and stick it in here. So 1, 0, 0, 0, 1, 0, 0, bunch of zeros. That 1 is for T, and that is our key. Because it's not in here, we'll initialize it with an array, and it would have the word eat in here. Then at our next iteration for T, we would also have to create a key for this. So we take T, and then for T, for the letter T, we would have a brand new array that's all set to 0, and we would find where T is, put a 1 there, find E, put a 1 there, and find A, put a 1 there, and then we'll get this brand new key. We'll take that and go into this hash map and see if it exists. We see that it's exactly like the first key, EAT, and because it already exists in the hash map, we will just push T onto that key. So we'll push T onto here. At the next iteration for tan, same idea. We'll create a separate key and turn it into a string and look it up in the hash map. We'll see that it's not there, so we'll input tan into it. So it'll be 1, a bunch of zeros, 1, more zeros, 1, and here is tan. And then our next iteration for 8, we create a key, we go through the same process, brand new array, all a bunch of zeros, find where A goes, increase the count to 1, find where T is, increase the count to 1, find E, increase the count to 1, and then we have our string that looks like this, and we go into our map and we see that it already exists, so we push it onto our array, and at the next iteration, we do the same thing, and we'll push it onto here, and at the last one, it's a unique key, so it'll live all by itself with 1, 0, 1 for the T, and that's our key. And at the very end, we just return all of the values here, and the values would be pushed onto an array, so in any order. So at the very end, we return all of the values of this object into an array. So it would be in any order, so it can be eat, T. So at the end, we would iterate through the object and grab all of these arrays and push them into its resulting array. So let's talk about time and space complexity. For time, it would be O of m times n, and for space would be O of n. M would be the number of how many strings are in this array. So for this case, it's 1, 2, 3, 4, 5, 6. 6 strings times n, where n is the average number of characters in that string. And in this situation, it is 3. So 6 times 3. For a very large array, it could be very big, and all of the words could be like single letters, which would be 1. So in this So for time, in the worst case scenario, this would be O of m, where m equals every single word in the array, times n, which is each character in the array, because we have to iterate through every single character in order to make a key. For space, worst case scenario, you would have to create a brand new key for every single object in a very large input array. For space, in the worst case scenario, it would be O of n, because let's say there are 1,000 words and all 1,000 words are unique. That means you have to create an object for every single word, or you would have to create an object with a key for each word, which would be 1,000. All right, so let's see what this would look like in the code. So first off, we would have to create a map that has all of the keys, and for the values, it would group all of the anagrams together into an array. So for let word of strings, strs. So for every single word in this input array, what do we want to do? We want to create a key for it. Key equals character counter of this word. So we'll create a little nice function here. Takes in a word and creates the key. So once that key is created, it'll spit it out, and we will look into our existing map to see if the key is there. If the key is there, we take that word and push it onto the array. If the key is not there, we create a brand new entry in the hash map. So we want to see if map.has key. If it is then there, what do? We say map.getKey.push is word because the key exists. Else, we set it into the map key and we initialize it with the word. At the very end, we return all of the values of that object into an array. Map.values. So that would take care of our map and what that would look like. Pretty simple, pretty straightforward. I think the tricky part for this question is figuring out how to set up the key. So to set up the key, we want to create an array, right? Remember, we have an array of 26 slots. And to do that in JavaScript, we do a new array with 26 slots and we fill it up with 0. And we fill it up with 0 because we want to increase the frequency character by 1 every time we come across it. So with our string input, so with our singular string, this is the string that we get from here. This word, we're going to loop through it for every single character for let char of str. We want to look up the index that corresponds to that letter. Remember, if we want to fill in the spot for E, we'd have to figure out where E is and put a 1 in there. And we know that that's at index 4. So in the code, that would look like in our array, we know that we want to increase it by 1. But here's the tricky part. So we take char.char code at -97. And then I'll explain that a little bit more in a minute. And at the end, we take that entire array and we turn it into a string. So we do json.stringify our array. That will turn it into a string where we can come back here. And the key is in a string format. And we go to check if the map has that key in string format. So I just wanted to go over line 10 to see what that would look like. So we have array sub char code at 97. So when we look up the ASCII table, we see that for E, right, because the current letter that we're looking at the very first iteration would be right here at E. We want to find the character code for it. So E corresponds to 101. And we take 101 minus 97. And why do we do 97? We subtract it from 97 because if we go back to the ASCII table, 97 corresponds to A. So we take 101 minus 97, and that would equal to 4. So we go into our array, and 4 is the index. So at 0, 1, 2, 3, 4, we find that this is where E is, index 4, and that's where we would increase the count to 1, right? That's where the plus plus comes into play. And let's run it for sample test cases. It looks good. And that's how I would go about it. If you like what you see, would like to see more videos, please feel free to like and subscribe. Hope to see y'all next time. Thanks for watching.